Okay, so first, I'm going to go over L factorization, one of the fundamental technique to decompose matrix A so that we can solve AX equals B quite easily without finding A inverse. So L factorization is to factorize matrix A to lower triangular matrix times upper triangular matrix. So here L is lower triangular matrix. And then U is upper triangular matrix. Okay, so why we have to do that? Because the goal is to solve the system AX matrix equation. AX is equal to B. Okay, so let's assume that A is in n by n matrix. So B is in Rn space, and the X R2. Okay, and now we want to solve AX bar equals B for any choice of a vector B. Okay, so then, and then, as I told you, it's hard to find out A inverse. So what are you going to do? We're going to use L factorization, which means that we're going to decompose matrix A to L times U. So why we have to do that? Because once we decompose matrix A to L times U, okay, then we solve the system matrix equation in 2 steps. Okay. So step 1 is to AX bar is equal to B bar. This one implies, and then, okay, so we decompose matrix A times L times U is equal to X bar is equal to B bar. And then let's say U times X bar is equal to Y bar. So which means that then LU times X bar equals B bar turns out to be L times Y bar is equal to B bar. So we solve it. So we solve Ly bar is equal to B bar by the forward substitution. Okay, and then step 2, once we figured out Y bar, then we substitute Y bar into so we solved this U X bar is equal to Y bar because we want to find out X bar, not Y bar. So we got Y bar in step 1. So we know Y bar what it is. And the U is upper triangular matrix. So we solve the system. U X bar is equal to Y bar by backward substitution. Okay. So that's the strategy. So now then how to compute the L and U? Okay, so how to compute L and U? We do this. We're gonna row reduce matrix A. Okay. The matrix to echelon form. Let's say EF. Okay. It takes A to upper triangular matrix. We know that once we when we row reduce matrix A, we'll get the upper triangular matrix, right? So which means that because when you to get the echelon form, we're gonna apply the elementary operations. But elementary operations is nothing but elementary matrix, right? So for given matrix A, we apply the sequence of elementary matrix to get the row echelon form, right? So then we're gonna get the upper triangular matrix. So this is how to get the upper triangular matrix which is L factorizations. So these are the elementary matrices. Okay. So here, but one thing that you should keep in mind that we assume that what the we only apply the think about this. How many elementary operations? Three, right? Replacement, interchange, and scaling, right? So we're not going to apply the interchange. We only apply replacement and scaling. Okay, scaling. So we don't apply the which means that we're not going to swap the rows. Okay. So think about this. While we don't apply the interchange, let's think about it. Okay. So I'll tell you later. So once you do this, then let's find out lower triangle matrix. So we already got upper triangle matrix, right? So how can you find out lower triangle matrix? We're gonna get clue from this, a sequence of elementary matrices. So for each elementary matrix, it should have inverse matrix, right? So now then A is gonna be is the E1 and then EK, right? EK through to E1, the inverse, and then U. So that should be the lower triangle matrix. Okay. So which means that this is equal to E1 inverse times E2 inverse, right? Because when you apply the inverse operator inside the parenthesis of a sequence of matrices, elementary matrices, you need to reverse order, right? EK inverse, then U. This is the lower triangle matrix, which means that this is equal to L. Okay. So then you may wonder that why the this is the lower triangle matrix. Anyone can answer that? Okay. So each matrix, elementary matrices are each elementary matrix is a lower triangular matrix, and the inverse is also lower triangular matrix. Okay, keep in mind that. Now then, a lower triangular matrix. Okay, so let's see example. Example second. Let's see. Oh yeah, so let's see example in textbook. Example 2 in textbook. Okay, so let matrix A be 1, -2, 0, -2, 5, 1, and 3, -5, and 7. Okay, so let me just to summarize. Let me figure out the step by step how to compute LU factorization. Okay, so here LU algorithm. So I'm gonna find out the L and U following the steps. So step one, gonna be reduce matrix A to an EF echelon form. Okay, the U. So U is upper triangle matrix. That's an echelon form, right? By elementary operations. But keep in mind is here elementary operation without interchange, right? Without interchange, row interchange. And step 2 is place entries is in L. So same sequence of row operations reduce L to I. Okay. So before applying step 2, let's find out E1, E1 inverse through the EK inverse first. Okay. So first one. Okay. So you need to reduce matrix A to echelon form. That's going to be U, right? So now what I'm going to do? We need to we just check the first pivot, right, which is 1 right here. So we make a -2, which is the non-zero entry below the first pivot in first column. Then R2 times R1, right, plus R2, and then replace this the second row with that. Right? So we got the 1 and -2 and 3 and 0, 0 and 1, 1 and 1 and let's say 1 and 1 here 1 and 7, isn't it? Okay. Okay. So from here we got the E1, right? E1. So this is that is equal to what? This is equal to E1 times A, where E1 is what? 1, 0, 1, 0, 0. Okay. And now what? 2, 1, 0, and then 0, 0, 1, right? Is it? Because we applied that elementary row operation into identity matrix. So we got this 2 times first row, and then adding it into second row, right? So we got this. Okay, E1. The next one is what? Here. I didn't apply the step 2 yet. Okay. So applying the step 2 in a algorithm, it's easier, much easier than doing this one. Okay. So so now what are you gonna do? See, we need to make the 1 in the third row to 0, right? So to do that, we just add minus R1 plus R2, replace it with this is R2, 2 and 3 and R3. Okay. So then we got this. Let me write it down here. This is 1, -2 and 3 and 0, 0 and 1 and 1 and 0 and then 6. Okay. So here we got E2, right? So this is E2 gonna be what? It's gonna be E2 times E1 times matrix A. So now E2 is what we're maybe here. Okay, E2 is equal to 1, 0, 0, 1, 0, 0, and 0, 1, 0, right? And then 0 minus 1 and 1, right? Okay, that's the E2, right? So then so we got the upper triangular matrix, right? So now that's the U. So this is equal to U is this, right? So then we can say A is equal to, right, the E2 minus E2 times E1 times U. E2 times E1 times A is equal to U, right? So A is E2 times E1 to the inverse matrix, right? Inverse of this guy times U. And then this is what? Lower triangular matrix. Let's find the lower triangular matrix. Then we need to multiply. Let me just multiply E1 and E2. Or you can, and then take an inverse. Or you just rewrite this one as E1 inverse times E2 inverse, okay, and times U. So which means that just take the inverse of E1, E2 for each, and then do multiplication, matrix multiplication. But let me do this one. So E1 inverse is going to be what? E1 inverse is equal to, anyone can find the E1 inverse? That's too much, right? We didn't learn yet, okay? But E2, E1 inverse is going to be, okay, is equal to 1, 0, 0, and negative 2, 1, 0, then 0, 0, 1. This is true. Okay, so this is LU algorithm. We're gonna define L and U. I mean, factorize matrix A into LU, L and U by finding the sequence of inverse of elementary matrices and reducing the matrix A to echelon form. That echelon form gonna be U. That's a okay. That's just step one in LU algorithm, but that one we don't apply the row interchange. And then the step two in LU algorithm, the difference between what we're gonna do in here by finding E1 and E2 and the inverse of E1 and E2. In step two in our LU algorithm, we're gonna place entry in L, so same sequence of operations, reduce L to I, which means that literally we store the columns, pivot columns, and then replace the columns in identity matrix with them, and then divide them by the pivot. Okay, so we got this one. This is row equivalent to that by applying that replacement. So E1 gonna be this. Okay, and then E2, and then also we apply the that row operations replacement, I mean. Okay, because to make we gotta make it 0 here in this entry. So E2 gonna be this. Okay. So finally we got echelon form. That should can be matrix U, which is upper triangle matrix. Okay. And then how about the L, lower triangle matrix? We're gonna find out inverse matrix of E1 and E2, and then multiply matrix multiplication, okay? Matrix multiplication of E1 inverse and E2 inverse, then we get this, the lower triangular matrix. Okay, that's kind of long story. So instead of doing that, applying step two in an LU algorithm, so we store the first column, then, and then the second, I mean, first and then second and third entry in the second column, and then the last column in the third columns, and then substitute entry in an identity matrix with them. So we got this, and then we divide by pivots for each column. So we got this. This is L. Okay. So let's see other examples. Another example is let's say what about A is 2, 6, and 1 and 8. So we simply apply the elementary operations. Negative 3 times R1 plus R2. Then replace it with R2, right? So then we got the 2 and 1 and 0 and the 5, right? So before doing that, we store this one. Okay, once we apply that elementary operations, we store that one too. Okay, so now then 2 and 6, and that column divide by pivot. What's a pivot? 2. And then 5, second column, we second, after applying the elementary operations, we got this. We divide this one by pivot. What's a pivot? 5. Right? So that is equal to what? 1 and 3. This is equal to what? 1, right? So that's a lower triangular matrix. And then this is what? Upper triangular matrix. So matrix A is equal to 1, 3, 1, and 0. Okay. And then times 2, 1, 0, 5. The lower triangular matrix, upper triangular matrix. This is how. Let's see. Okay. And now let's solve the system. Okay. So the example, one more example. So let's say A is the AX bar is equal to B. Let's consider that system. Here A is equal to 1 and negative 2 and 3 and negative 2, 5 and negative 5 and 0, 1, 7. Okay, here B bar is equal to 1, 1, 1. Okay, so solve this system using LU factorization. Okay, so step 1 is find the U. Yeah, by reducing matrix A to echelon form EF. Okay, so matrix A is given 1, negative 2, 3, negative 2, 5, negative 5, 0, 1, 7. Okay, so let me skip, finding, elementary, applying the elementary operations. So doing this, we got the 1 and negative 2, 3, and 0, 0, 0, 1, and 1, and 6. Okay, so that's the U. This is the upper triangular matrix. Now step 2. So we still while you apply the elementary operations, so we got the columns, right? So using them to find the lower triangular matrix by dividing each store entries is pivot. Okay, and placing the result into L. Okay. So while you do this, you got this 1, negative 2, 0, and then 1 and 1 and 6. Okay, so we divide the first column. List of entry, you can say that, divide by 1, because pivot is 1. Divide by 1 for this one, and divide by 6. Okay, so doing that, we got L. It's 1, negative 2, 0, 0, 1, 1, and 0, 0, 1. Okay, now step 3. So express A X bar is equal to B bar as what? LU times X bar is equal to B bar. And let what? Y bar is equal to UX bar. Or UX bar equals Y bar, it doesn't matter. So we solve the LY bar is equal to B bar. Okay. So then this 1, negative 2, 0, 0, 1, 1, and 0, 0, 1. Right. Is equal to Y1, Y2, Y3. So 1, 1, 1. It means that what? Y1 must be 1, right? And the Y2 must be 3. And the Y3 must be negative 2. Okay. So we do the forward substitution. Okay. So now in the step 4, so we solve what? the lower triangle matrix times y bar is equal to, yeah, x bar is equal to y bar. Okay. So we got the y bar in step 3, and then put this one y bar into that equation, and then we solved it. So L is what? 1, -2, 0, 0, 1, 1, 0, 0, 1. Okay. This is times x1, x2, x3. This is equal to y bar. What is y bar? Is a 1, 3, -2. So using backward substitution, we can find x1, x2, x3, right? X1 must be 1. And then x2, what was x2? X2 is 5, right? And x3 is this is a 5. So -3, isn't it? -3. Oh, no. -7, isn't it? Right? Is something wrong? Oh, yeah, that was u. Oh, so what's the u? U is, let me copy it. Let's copy. Paste. And then x1, x3, right? X3 must be 6. And then x2 is 3, right? Oh, no. No, this is the 1/3, right? The x3 is let's see. This is 1/3. 8/3, right? And the x3 is gonna be x1 is 2/3 and 26. 22, right? -21, -7, isn't it? You got it?